We're currently at Willem Twee, and this is Studio One. You may have seen this rack and stuff in various other videos, but I thought we should ask Hans, who has been building this up over multiple decades, this collection and the patch setups and everything, and we may as well ask him a few questions about what is actually going on and how it's all actually interconnected. So, Hans, how you doing?
Yeah, I'm right? Fine. Very good to have you here.
Thank you for having us.
Right.
We let's have a look at what we got. So we should start this side of the room, shall we?
Yeah. What you see here is early test equipment from the 50s. It's all tube. It's nice heating, but it's mainly just sine waves. But it's a very good type of sine wave. It's a Wien bridge, you know that type. Mm-hmm. It's actually a resonator, so it has very low harmonic distortion. And the first electronic music was done with this kind of things, instruments, at radio stations. So they had one, and it was on the technical in the technical department, you know. And Stockhausen started to work with it and just had a phone. Like, can I have 1K? Mm-hmm. Yeah, okay. And then it appeared on the mixing desk, and on and on and on. So, but I'm a bit of a lazy person, so I have 12. 12. But
it's cool because you can play the chords. So so they're numbered 1, 2, 3, 4. That goes over to the patch bay there.
Yeah, they get in here.
And then they come to the mixer.
And they come to the mixer. So, for instance, number 1.
Oh, very nice.
And it's such a pure sound. And you can tune it as you want.
Very cool.
See?
Oh, I've got a fiddle one. I've got to twist at least one. The one that wasn't on.
Yeah, the one that wasn't on.
That's all right.
So then, actually, it's just static sound, right? So you make your amplitude, actually your envelopes or whatever, you do it by hand. See? And then this submixer output comes back here on the main desk for recording or tape recording, but also to connect it to a ring modulator, for instance. You get this kind of sounds, and then you can really transpose the sound to totally, right? This one I got from Rob Hordijk.
Oh, really?
Yeah.
From Rob.
Rob is with us still, so that's cool.
Amazing.
So also here you can, you know, make it move a bit.
Mm-hmm. Awesome.
So then you can make all kinds of atmospheric pads and record it and then make another constellation of frequencies and then record that and cut it and splice it. I thought it would be interesting to also have pulse waves.
Yeah.
So Rob, our volunteer, built this 12-channel sine-to-pulse converter. And so now we can have a pulse with pulse width. See?
Yeah.
And then you have quite an enormous amount of spectral information. Mm-hmm. And then that will be interesting to filter, of course. So we have these 3 filters hooked up also through pre-fade. So here we can make all kinds of colors. Mm-hmm. and of course still remodel it, but it becomes a bit harsh, right?
That's awesome. Nice.
So most of the time when people come here, I first put them on this side, just to get a bit more comfortable with the situation and just tune a bit. And most of the time, after half an hour, people are gone, you know, recording.
This oscilloscope is wired up to the mixer as well for a visual representation of what's going on here.
Exactly. In fact, the first oscillator is put on the horizontal.
Oh, so number one is the time base.
Yeah, actually.
This
Yeah,
is
the
time
reference.
base. Yeah,
and
okay.
then the other ones come up like this.
I see.
And then you can tune it to be harmonic.
Where's number two?
Yeah, that's the tuning. Yeah.
Oh, that's a hand. And then if we bring another one in, we've got number three.
Yeah.
Oh, we'll find one. Oh, and then another four, I guess, whilst we're here.
Yeah.
And then we change the time base. So if we flick it, I guess we can speed it up by flicking this one. This one's the horizontal. So if we get this really... Oh, where's the quick? Where would we get it really speed it? We'll bring it down, let's bring it down. Actually, let's bring it down. Oh, we're getting really slow, and then we can bring it up to... Oh, there we go.
Yeah.
Something, we get a happy point. The happy points. So now we're dancing with the frequencies on the drum.
That's the same frequency.
Now we're in.
Now it's the same frequency, but with a little bit
And then when
of
you get,
phasing.
you get out of that phase slightly, and you get into. And if we can hear both of them.
Yep.
There we go. There's a harmony. Beautiful. So yeah, it's a good visual representation, but that's not the only thing that's coming in here for visual representation, is it? You've also got the switch, so you can also read.
Yeah, because you know the dials are not very precise. So if you want to make lists with very precise frequencies, you can read it out here. See, so for instance, number 2. If you turn on number 2, it's now on 160.
Now, if we flick it over to, if we get it bang on the same as number 1, there, nearly-ish, which is what's that now? 201. Hopefully, if we flick it over to number 1, it should be nearly the same. Oh.
Yeah. It's.
Oh, it is an octave. That's weird. Doesn't feel like.
Yeah, that's a bit weird.
Well, let's try and match it then. Okay, so we're at 400 now. So we go. Oh no! Let's get up to 400 on number 2. Are we on number 2? Oh, I've got a long way to go. Oh, I'm on the big one.
Oh, you're on the edge of the.
Are we on 400? So we're on 400.
Yeah. Now
here we go.
Yeah, but
looks
now
like a double.
Now it's an octave.
That's weird, isn't it? So
yeah.
Maybe it's listening to the fundamental that we're not here. So number 1 is 400. Number 2, 400. Very strange.
Yeah.
This is the thing. The setup. It's so much full on that there's even still surprises 30 years later.
Every day.
And then we bring the wigglies in slowly, and it starts looking like an evil smile. Beautiful. So. That's the sign. That's the signal generators going into this setup.
Yep.
We move over, and it starts getting a lot more funky over here, right?
Yeah. Actually, this side is I got for studying the first electronic music, just by having the instruments, you know, to explore it. But this side actually comes from getting into the analog computer.
Ah.
And then when I did research on the computer, I got this fantastic noise generator from a guy from the Technical University in Delft. And I immediately fell in love with the quality and the precision and the range, you know, it's. So I slowly but gradually found, and I like the aesthetics.
Yes.
And also, when you have stuff from the same brand, it has a certain design philosophy. So all the knobs and controls are the same in a way. So it helps you to get quickly to things and get a muscle memory or something.
So that's why we have Roland Sports sat over there, signal generators, the odd passive filter here, bits like that. It's all Roland Sports, same design philosophy. And then as you're mentioning over here, it's Hewlett-Packard stuff. This being the first one, right?
Yep.
The noise, which we're going to listen to. He showed us it earlier. It sounds really cool. And even this is the, what did you say? This was the first octal Hewlett-Packard computer, correct?
Yep.
Work in progress still, but it's cool to have it sitting there.
Yeah.
Well, shall we have a listen to this? You've got it set up, haven't you?
Yeah, I got it hooked up now here to show you this filter.
Yeah.
Which was used originally for acoustic measurements. And got some sound. And then through the pre-fade aux, I put it into this filter, which is a third octave filter. And I made individual outputs for each band here. So I now selected some bands to have it on the desk. So.
Oh, very nice.
See, now you can sort of play it. And because you can send these individual channels to that same system again, you can make it feedback. Like this.
Yeah.
To have the peak smaller, you know, more resonant, make it more resonant. Ring modulate this, you hear this. Which is more industrial kind of. See?
Yeah. So, and then.
Yeah, you can also play with this. Yeah.
That's cool. So that's ring modulated. So it's coming from the noise source. So the noise source gets sent into the filter. That's dry.
Yep.
Gets sent into the filter. The filter comes down, and these are the separate filter banks from the lowest. Oh no, that's not the lowest. Oh yes. Oh well, it might be mixed up somewhat.
I made a selection here.
Yeah, so I made a selection into the mixer. So you were getting some cool sounds, different sounds from that as well.
Nice thing. Let's take this. It's actually a pseudo-random sequencer, so it has a clock to have it run very slowly, but it also has a binary output.
Oh, this is it's like a ghost ship. The ghost ship of doom. Wow. Woo! Going off on one. So the dry sound of that would be like, you can hear it like, that's it without the filter, so that's directly from the binary output of the noise source. What would it's called a noise generator, but it's also interesting.
Yep.
And then you send it through the filters. You get some magic sounds. So there's also a display output as well. We've got another display for this mixer. So have you got them split up? So we've got a display for this setup.
Yeah.
And then a display for this setup.
Yeah.
And then Yeah.
But you definitely hear it's random, but it's clocked, so it's stable. So I've modified this one to have external clocking,
Okay. Yeah.
and then control it with a random signal, and then you get really random pulses.
So if we unplug this from, that's the output, we're going to there.
Yeah.
Go on, then give it a go. Let's give it a whirl.
But then we need to put on this one as well, and an oscillator.
The other thing is the standardization of this has got set up is actually running on BNC connectors, and that's because the primarily test equipment BNC isn't it you're using.
Yeah.
The BNCs.
So now we clock this externally, put it on pulse. Let's see what's. So now this is. So, but we can also, yeah, you have a very short one now. So now I use a bit of random frequency modulation on the clock.
It's going in.
See, so now it's really irregular.
So you've got, so the noise, there's another noise. So we got this noise generator. So this noise generator goes into this.
Yeah, the frequency control of this one.
Yes.
And this one is very low. Low frequency makes a low random voltage to control the pitch of this.
Ah.
Yeah, now it
Going
goes
mad. Yeah.
louder. See?
Ah, yeah.
It's a bit too much.
Cool, though. It's amazing. And that controls this.
So, and that controls the clock frequency of this one.
Yeah.
Yeah.
And I'm assuming around the back of here.
Yeah.
So there is a connection. There's something being connected to the back.
Yeah. I put it in front here.
Yeah. So it's all broken around. Around the back's really interesting as well. Like it's all intertwined. Like the amount of time. How long do you reckon it's taken to get this set up to this point?
A few weeks.
A few weeks.
Yeah.
Wow.
If you say we had to move it from my house to here.
Oh yeah.
First, make bolt all the racks together.
Yeah.
And then slowly, but gradually put in things. And then you make mistakes. You say, oh, it's too long, or you take it out again, test it, etc.
Well, what are we looking at next?
Well, instead of this, listen to this one.
Okay. So this is
a pulse generator with its own clock, and you can set the pulse width, of course, the rise and fall of the pulse, the amplitude, and you can make a double pulse. Okay. So it's also very nice to when it runs. Run. Here we are.
Oh, double.
Yeah.
Oh, shit.
But it's so acoustic, so vocalish, acoustic.
And that is thanks to the filter largely.
Yeah.
So it triggers and then into the filter, which makes it sound so...
Yeah.
It sounds like it's in a cabinet. It's got a sort of cabinet sound to it. So, yeah, dry again. That's the dry from this one, isn't it? And then you can soften... Oh, wow, yeah, you can get it to the point where the rise is overtaking the actual... Ooh. Wow. Nice.
So we could exchange this one for this output.
Okay.
And now we have this very slow.
That's the. This is This is now modulating that.
Yeah.
So it's a
the pitch.
A super low frequency oscillator, LFO extreme. So if we do it quickly, and then
Yeah.
Literally sounds like a human voice.
yeah. And then we go to the really slow one.
You nearly notice.
Yeah, you don't even notice it's so slow. Ring mod. Crazy.
But with these machines, we can make some rhythmic patterns.
Ah, yes. Word generators. Okay.
Yeah. Shall I prepare something for you?
Yes, please. So let's have a look around the back now. I mean, it's just as useful and as interesting as the front for people like myself. So let's have a look. This is the back of the signal generators, the Roden Schwartz stuff. Not initially intended for the 19-inch racks it's in, but they've been bolted in place, so they're not going anywhere. They're not going to fall on you, so it's all right. But they're all stacked up here, and we get over to this part, which we all actually connect up to. So all the signal generator outputs go over to this. We've got a sine wave to square wave converter for each of them. That's the switches we were flicking at the front. There's the circuit board on the back. It's all custom here. You've got the patch panels. It's all intertwined, been very well thought about. We keep on going along. The mixing desks are down here. You can see the back of them. We're starting to get to the Hewlett-Packard setup here. This is where the computer is. This is a work in progress. It's going to be worked on, I can imagine. There's a patch panel. This is the back of it. You'll see it's empty, but that's all going to be soldered in place to be able to talk to the bit addresses on the computer. I think that's what's been said. And then we go over to the rest of the Hewlett-Packard stuff. There's custom bits dotted in and about. In fact, I think, which one's the code? This one is the one that's been modified for a clock in. So it's got a clock input, and that's what we were fiddling around with earlier. Going down further, there's a custom one here, which is 16 VCAs. VCAs are very useful for test equipment, but you know you don't find them a lot. So custom VCAs to turn things on and off with voltage, very useful. As you can see, there's other custom boxes here and there intertwined into the stuff. But yeah, it's all very neatly put together in these very nice solid 19-inch racks, which I have heard have been repurposed in the past from PDPs. They might big PDP mainframes. And then you can see over here, this is the back of the analog computers that are at the end. We'll be having a look at those in a little moment. That's very cool. So, you know what you're doing, don't you? So Hans has now set up a beat using the word generators that are down here, the Hewlett-Packard word generators, if you have a look at this. So these basically send out bit pulses, and they're being repurposed, not for what they're intended for, but for making musical beats.
The third one is pulsing this one, these two band pass filters.
So these have been nice. So this wire, the input of it, that's coming from all the way over here, as we go over here from this thing, right here.
Yeah, actually here.
So that's the output.
I put it out here, into this, it goes all around the back to the input of the, just to avoid a lot of, you know, wires all over. And
this is really.
but you can also say, okay, this is all on 16. You could say, well, let's have one on 12.
Okay. Yeah. I see.
Get it a bit more like
150 and we're going. Oh, he's bumping around now. So as you can see, these switches, if we turn, let's
yeah, you can.
0 is off.
Yeah.
So we turn them all off. It's basically a drum sequencer, but for people with lab coats. Nearly. Turn them all off first.
Put them all off.
Let's get them all down on 0. Oh, you've got one Z. Oh, just how many of these have you got?
3.
Blimey,
With the 2 channels each, so you've 6.
It's still a. Okay, so yeah, and then if we start flicking through these buttons, so these 2 are the ones over there, are they?
Yep.
This output. So output A, we're going to start pinging it, and then we get. So we've got this little sound, but then if we go, and then follow me, come over here. We go over to these filters, and of course, ruin the beautiful pinging sounds that Hans has made. We'll start making them, and then we could get, and then they're tuned. That's mad.
And the thing is, the filters react to the rising and the falling edge of the pulse.
Yeah.
So if you want to have them longer, let's say we have this one. Ah, yeah.
Sounds like a CS78.
So that's on, off.
Exactly.
In fact, if you look at the overload LED over here, you can see that it turns off. So pulse on, pulse off.
And actually, this is now the clock with the pulse. This runs to a multiple and clocks all the word generation at the same frequency. So you can make, let's say, tempo adjustments here.
So speedy,
Yeah.
and then flick it to Crazy Town.
And now this whole lot, so this is the tempo, right?
Ah,
This whole lot. Now through
ooh,
you get a kind of, you know, metallic gamelan
sounds like Paul
type.
Simon.
Yes.
That's amazing. Ooh.
And then of course you can mix it with some.
Bring the drones in. Because that's of course coming through the ring modulator as well.
Yeah.
Ah.
In this case,
Yeah.
I could separate it.
Oh, you got delay going on. Ah, Johnny.
Good stuff.
Very speed, of course.
So, right now this is acting as the delay. Is that correct?
Yep. It is being recorded here on this record head,
Yes.
and it's playbacked, and it's fed back to the record head. So this distance between record and play makes the amount of delay in relation to the tape speed. See, this is faster, so shorter delay.
Yeah. And because you've got it coming back into itself at the same time, there is a feedback control over there. So it's basically a very big, fancy copycat. Oh, that's got some. Is that on feedback?
No, that's what is on the tape before.
Oh yeah, I'm not doing record yet, idiot.
Yeah. Exactly. And then, now it goes to everything. And you, with variable, you can set the amplitude of the bands.
Ah, that's the one. Yeah, nice. So now we're going to be looking at the Spectrum Shaper Brawling Cure, which is a comb filter, and it makes some mad noises. Could you describe what you've done?
Yeah. We take just noise from this one, and through the pre-fade out, I sent it to this filter, but everything open, totally open. It's a third octave, but something strange happens when you take the output and put it together. And do a little bit of feedback here. And this is sort of a signature sound from early Dutch electronic music. You hear it a lot with Jan Boerman, all kinds of people. They use this kind of sound. Every octave divided in 3 major thirds.
Yeah. So I guess if you bring some of this down, you can notice where the effect will disappear.
Yeah.
So we bring it all in. We've only got the middle. Even if we bring the noise, you can hear what the filter's doing on its own.
Yeah.
And we bring it all together with the. And then bring the noise back in, and it sort of fades into itself and becomes this crazy space. It's like it takes a little bit of fine tuning to get it bang on, doesn't it? There. Oh.
Yeah.
Very strange. And I guess if you adjust the noise, bring it down a bit.
Yeah, you will filter it if you slow it down.
Yeah.
But if you take the binary out.
Ah, okay.
Yeah.
Then you get it.
Yeah.
It's weird about how it felt like you could bring the standard in and. Yeah, that's cool. Should we have a look at the analog computer?
Yeah, let's do it.
Oh, come and have a closer look on when they're turning on. It's really cool. The overload indicators go crazy. Yeah, lovely jubbly.
This one is running.
So, how do you use this in a musical realm?
The nice thing about an analog computer, you can run it very slowly, slow signals, so you could use it as a control voltage generator. Mm-hmm. But by switching to smaller capacitors, you get up in frequency and you get in the audio domain. There are all kinds of circuits to do, chaos, pendulums, etc. And you can program it on this board. You can program it offline if you want.
Ah, yeah.
So other people can work first, and then here you got your patched program. So we could make here, let's say, a panel with filters, or a panel with damped oscillators, or a chaos patch, or Oh, whatever. You can make mixers, sequencers, all kinds of things. And here are the modules. See, all the contacts in and out are brought to the front. And on the back there's edge connectors for the power supply. And these modules look about like this. See, this is a function generator. So here's the edge connector for the power and the monitoring. And here's the circuit. Here are the contacts.
Yeah,
see?
and the cool thing is this is actually a tool that's specifically made. It comes off the front of this one, and you use this, you plop it on that, twist it in so you can pull the cards out.
Yeah.
It's cool. But I guess this is only going to work with this one.
Yeah. It's special for that one.
And for people who possibly aren't aware, analog computer is, I mean, it's got all of the building blocks of a modular synthesizer, or a synthesizer in a way, isn't it?
Actually, and the fun thing is about this is that when you look at certain modular synth functions, it was already there 20 years earlier in the analog computing. So also things like sample and hold.
Oh, really?
It's in there.
Oh.
You know, multimode filter. It's in there. It's just an equation, but multipliers as well.
Yeah.
To be used as ring modulation or VCAs.
And also you've got sequencers.
Yeah, I got some counters here, some logic.
And you could, in theory, wire these up to the potentiometers via the potentiometer panels. And have a boop, 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 boop,
Yeah,
if you wanted
exactly.
to.
But you can also, these are the integrators, which is the magic of the analog computer, because that is a thing that runs in time, that makes a process in time, depending on the values of resistors and capacitors. That's the thing. So I've patched here something. Could be nice to show. And I put the outputs to an oscilloscope here. Got this one here. And let's see if it works. Yeah, something's happening. So now I got just one straight signal from this circuit. But when I take the outputs of both integrators and put it on X, Y, then you get something else. And I guess now I can make a sound.
Yeah.
Because actually this is a circuit now where we input the signal from here.
So you're getting the input from the signal generator.
Yeah, from a pulse one.
And that travels into where?
Comes in here, just into the circuit.
And then this is acting as a multimode filter?
Yeah. So, and here you got the frequency. See, you can hear. And this is the resonance. See? So you have just a nice filter.
Yeah. Or so you're pinging the analog computer right now.
Yeah, just this little circuit.
Yeah. And I guess we've got this sound which is being pinged by that one.
Yeah.
I guess if we get that coming out of a word processor, then that will go.
Then you do the same like pinging this.
Yeah.
Because this is actually a hardware version of this circuit.
Yeah. So,
right?
So that is basically in that box already. So the sound, the drum beat that we had just earlier, we can also bring this in.
Exactly.
Can't we?
And you can program 6 of these cells
pins
at the same time and control them.
So I guess if we unplug this, is that correct?
Yeah.
And we go into
put it in here.
Into the output of here, and then we get it to play. Oh, it's already playing.
Yep.
Okay. So now it's coming from the sequence from the word generator, and then we can potentially bring in the other sounds that were coming before. Just got to remember where they're coming from on the mixer. Oh, they're there, yeah. So now we've mixed the analog computer in with the drum beat that we had. And let's adjust this.
So I can show you now how it oscillates on its own.
Oh yeah. So, and we could probably make it a little bit quicker so it resets. And then we, the same knobs.
Yeah.
Or is it the top? Oh, it's the
No,
top
the
one.
down. Yeah.
This is damping. But this was also resonance as it was acting as a multi-mode filter. Is now gravity or dampening in this situation.
Yeah.
And then this one, what's the middle one?
Those two,
That one.
for those first two, are both for the frequency. Yeah, you can speed it up.
Oh yeah,
See?
yeah. Make it really quick. Ooh.
Yeah. Oop.
And make it.
Yeah.
Cool. Nice.
This is now to be set at real time, which is the larger capacitor, so we go slower in the process, but we can switch it for the whole system into repetitive operation, which is the smaller capacitors, and then the whole frequency range comes up.
So that's when the scientists are in a bit of a rush.
Yeah,
And they want to figure it out quicker.
Yeah, you can speed up the simulation 100 times.
Okay.
That's the idea.
Sure.
Yeah.
So these analog computers also have the control panel, sequencers, flip-flops and this and that. So
Yeah.
you can actually sort of push this button, is that all?
Yeah.
So we've got a sequencer running, so this is going bloop, bloop, bloop. Right, the challenge is, how do we get that plugging into this? Oh.
It's no challenge at all.
Oh.
But let me see. It's always a thing of wires, right?
Yes.
So what is happening here, we got a clock
Yeah.
signal. It goes into run of this decimal counter. And the carry of the counter runs the second one, so that makes it slower. So now we can count between 0 and 99 steps.
Yeah.
And by taking out positions of the counters and end it together,
Yeah.
and we can actually decode a certain point where we switch a flip-flop. And that flip-flop can control things like this thingy. No, like this.
Okay.
Here.
Okay, so good.
There it goes.
And that's been tricky.
See, this is the flip-flop that is...
Yeah, yeah. Ooh. That's for a pretty... So now it's sequencing itself.
Yep.
So that's an overview of Studio One at Willem Twee. You've got the signal generators, all of the stuff over here that goes into the mixers, you've got the filters, and you've got all the Hewlett-Packard stuff and the analog computers. You put it all together and you get some sounds.